Hey, how's it going? So I just wanted to give a quick introduction into Zeta because it's still like very underrated compared to some of my other projects, but this is definitely one of my best pieces of work. I've built hundreds upon hundreds of paper implementations with this framework. And basically, our goal is to essentially modularify neural network engineering and deep learning as much as possible. Yeah, essentially the goal is to make this as like the easiest possible framework to use to build neural nets, and also the most powerful um, at the same exact time. So let me go run over it and show you how to get started. So you can get started just by pipping installing Zeta with pip install Zeta scale. So just run pip install Zeta scale and you will have it. Now, we have a couple of super cool abstractions that I love using. For example, we have multi-query attention, which I use a lot of my projects. It's a really fast attention. This is the attention that Noam Shazir made, which is undoubtedly like, well, he made the transformer, but he also made this attention. So I think this is currently like one of the best forms of attention you could have, and then you could add things on top of that like rope, alibi, positional embeddings, and a lot of things like that. So Zeta has a lot of cool stuff. We have attentions, we have activation functions like swigglue, we have relative position bias, which is not really used that much. We have feed forwards. This feed forward class is really extensive. We have a bunch of different features for it. You have glue. You have a post activation layer normalization. You also have bit linear, which I worked on from the BitNet paper, which is also really good. We have the ability to generate models really quickly. This is the model from the Palmy paper, and you basically just import Torch, Zeta, autoregressive wrapper, decoder, encoder, transformer, and vision transformer wrapper, and then you could build this pretty easily. And so we have a lot of different modules here. We have activation functions, we have tensions, we have optimizers. I mean, we have a lot. And the main reason why I'm posting this video now is because I just made an update and just made it simpler to use. But I definitely think Zeta is extremely underrated because just how simple we make deep learning. We have a lot of activation functions: fuse, dense, gilo dense, fuse, dropout, layer norm. We have Mamba, of course. Where's Mamba? Yeah, you can look how simple this is. You can use Mamba like less than 10 lines of code. Then we have film, hyper optimize. We have DPO as well. Look how easy DPO is. And we also have some, logging stuff. We have sigmoid attention. And yeah, we have so many other things. The docs are not really kept up to date. We do have documentation, but it is not kept up to date because I need assistance. I can't do all this by myself. So I'm looking for help to maintain this because this is a really good project. I just can't do everything now because I'm working at Swarms and trying to get Swarms to do really well. So which this is like my second favorite project that I've worked on because as I mentioned before, you can build neural nets very quickly, and we're essentially trying to modularify building neural networks as much as possible, essentially. So I just added in a new module which is called the Muon optimizer. It's essentially like one of the best, fastest optimizers. And if you pip install Zetascale, and you can copy this code, I'll paste a file in the video description so you can have it. But yeah, basically you have your PyTorch. Let me move this into the root. Yeah, so you basically have your PyTorch code. Then this is just a simple model just to see if it works. But then we have Muon, and then we have Atom, and then we can test both. So yeah, I'll show you how it works. So every module in Zeta comes with logging, documentation, types, and more. We're trying to make it like the best possible framework to build neural nets and as easily as possible. So yeah, check it out. We have let me make this bigger. We have it kind of mimics the same library, like the same structure of PyTorch. So we have attention, we have biases, embeddings, mask, modules, quant, which is quantization. Then we also have just like mathematical operations. We have optimizers, which Muon is here. Line AB is here. We have a bunch of decoupled optimizers. We have some RL stuff. We have some tokenizers. We have some training. We have FSD, Hive Trainer. We have utils, a bunch of stuff. And yeah. We have a lot of stuff in Zeta. I just haven't been able to write a lot of documentation about it because it's very time consuming. So maybe we can automate that process with agents to create the documentation. So yeah, that would be very nice. And I'm actually going to push another update right now. Yeah. So if you agree with the mission of making, the most powerful and simplest neural network framework to build really production grade neural nets, please join us and check out the code. Let me know your thoughts. Let me know what you don't like, and submit some pull requests. Fix some bugs, add documentation. We need a lot of documentation, and also testing. We need to make the testing really good. So yeah, let me know. And thank you for watching this. Join the Agora Discord if you like. And yeah, subscribe, hit the like button, and thank you. Appreciate it.